Here's a really good Pthag trig question. But before we get to the Pythagoras part, I could show you how there's one little twist in this question. But you can get these first three questions right just using the things we learned and did every single day in class. One of them is, it says the cosine of 41 degrees is p. Expressed without using a calculator. You can't go the cosine of, and then write it down. What is this going to be, the sine of 49 degrees in terms of p? Well, the cos of 41 is equal to the sine of 90 minus 41, whatever adds up to 90. So cofunctions tell us that the cos of 41 is the sine of 49. So the sine of 49 is the same as the cos of 41. It must just be equal to p. Let's try this one, the cosine of 319 degrees. Well, you just have to go to where it is, and we're going to reduce it. You start at 0, you go all the way around, you don't quite come a full 360, you're 41 degrees short. That's the reference angle, so that's just the same as the cosine of 41. Oh, it's just p as well. Okay, let's try this one. Now, it's a little bit harder because it's negative 139. So you start at 0 here, and you bend in the clockwise, and you bend not a half turn, that'd be 180. You're 41 degrees short of minus 180. That's a reference angle of 41 degrees. Except what quadrant are we in? If we're here, if you start here and then you bend, imagine 3 quadrants here. If you bend towards minus 180, you're in the 3rd quadrant, and cosine is negative there. So the cosine of negative 139 degrees is the same as the cosine of 41, but it's negative. Well, the cosine of 41 is p, so the answer must be minus p. Now, to get the last question right, you've got to do some Pythagoras. Now, it says here that the cosine of 41 degrees is p. Well, here's the trick. Instead of writing p, you can make it p over 1. And the cosine is a fraction, a ratio of adjacent over hypotenuse. Now, all you do is draw yourself a right-angled triangle, put 1 on the hypotenuse, and put p on the side next to the 41 degrees you draw. And it's going to look like this. P on the adjacent side, 1 on the hypotenuse side. But our problem is, what's this other short side? Oh, it's Pythagoras. If you're looking for the short side next to the 90 degrees, you're supposed to square both sides and subtract, and then take the square root. But 1 times 1 is just 1. So this opposite side must be root 1 minus p squared, you see, in terms of p. That's the little trick. Now, you could still get a mark, even if you didn't draw the triangle. If you went tangent of 2, you went to where 221 degrees and realized that it was really the tangent of 41. 41 past 180. But now, just to get the last part, you're going to need opposite over adjacent. That's what tangent is. So it's root 1 minus p squared over p. It looks strange, but that's how you do it.